Welcome to Two Bees in a Podcast, brought to you by the Honeybee Research and Extension Laboratory at the University of Florida's Institute of Food and Agricultural Sciences. It is our goal to advance the understanding of honeybees and beekeeping, grow the beekeeping community, and improve the health of honeybees everywhere. In this podcast, you'll hear research updates, beekeeping management practices discussed, and advice on beekeeping from our resident experts, beekeepers, scientists, and other program guests. Join us for today's program, and thank you for listening to Two Bees in a Podcast. Welcome to Two Bees in a Podcast. In this episode, we will be interviewing Dr. Martin Benzik from Nottingham Trent University. He will be here talking to us about some of his latest research on interpreting the sounds that queen honeybees make and using that information to predict when colonies will swarm. In our second segment, we'll be joined by Dr. Malcolm Sanford, a former professor here at the University of Florida, and we'll be talking about his career as an extension specialist here at the university. And of course, the podcast would not be complete without everyone's favorite segment, Stump the Chump, or Questions and Answers. All right, listeners, we have an academic treat for you this morning. Amy and I are at our respective homes, and we are recording this podcast. It's actually July 1st, 2020. And back in June, just last month, a very interesting manuscript was published. It's called The Prediction of Swarming in Honeybee Colonies Using Vibrational Spectra. That paper was published in Scientific Reports. I know it's important to beekeepers because a few beekeepers have shared it with me to ask me my thoughts about it. It's going to be linked in the show notes so that after you listen to today's podcast segment on this topic, you can go back and read the paper for yourself. To talk about this manuscript and the findings with us, we are joined by Dr. Martin Benzik, who's an associate professor in the School of Science and Technology from Nottingham Trent University. That's in the UK. Dr. Benzik, thank you so much for joining us on Two Bees in a Podcast.
Thank you for inviting me. I'm looking forward to this chat.
Me too. So, Dr. Benzik. Benzik, is that how you say it?
That's how you say it. It's a Hungarian word, family name.
Oh, very nice. It's a very beautiful name. So, can you tell us about yourself and kind of your beekeeping journey? We love to hear everybody's story, how they kind of got into beekeeping, and if you're not a beekeeper, how you got into beekeeping research. So, we'd love to hear just about you and your journey.
Sure. So, both my mom and dad are Hungarian. Beekeeping is a big thing in Hungary and also in Yugoslavia, further down the south in Europe. So my dad started beekeeping in his 40s, and I was a very young child. And I was surrounded by bees, being a little boy, and very much hated it. My dad took me to the apiary. I helped him doing some of the beekeeping. Bees always buzzing around me. It was really annoying me. I got stung on numerous occasions, and as a start of an encounter with honeybees, it was very unpleasant. But he gave me the opportunity to spin the honey, and he promised me the income of selling the honey if I did so. So for my own pocket money, I started spinning the honey every summer. And yes, indeed, any jar that I sold, he let me have the income for my own pocket. So actually, that was quite lucrative. I could buy my lemonade, the odd new tire for my bicycle when needed. And people loved the honey, and it was very satisfying, that part of the beekeeping. So I kept going with this until probably being a teenager. And then I had to stop. I studied at the university. I did my military service, etc. And then settled down in the United Kingdom, where I became an academic. And I was still not particularly interested in beekeeping, in bees or insects. But we then had a boy, my wife and I. My wife is British. I'm married in England. And when we had our boy one morning for breakfast, we were sitting in our kitchen with a window onto the garden, and there was a cobweb outside on the corner of the window, and the three of us were having breakfast, and I walked out into the garden. I carefully picked up an ant and I deposited it onto the cobweb. And my son, he was 2 years old, and he became absolutely transfixed at witnessing the spider detecting the presence of the ant by the vibrations that were taking place in the cobweb. And then the spider made a beeline to the ant and wrapped it around with silk and stored it. And it was a fascinating phenomenon for him to witness in the first time. And following this, it was impossible to go out on a walk with my son without him stopping at every spider cobweb that he saw, making sure he picked up an ant and making sure he fed carefully every single ant we encountered on our walks. So because of that, he actually became very, very interested in spiders and insects, and he would pick up any insect and any spider that we had on our walks. And because of that, and because he was little, I had to hold a spider in my hand on numerous occasions with him. And obviously, I was a grown-up man next to my 2-year-old boy, and there was no way I would escape that thing which wasn't particularly attracting me to have a spider in my hands. But I soon did it to help him, to help his passion, and I soon realized that there was no problem at all holding a spider in my hands. In fact, quite the opposite. I very soon enjoyed it. And I was amazed at the beauty of a spider, witnessing her or him in my hand, crawling around me. And I soon forgot any particular feeling of being put off that I used to have as a child, of having an insect crawling on me. And so that started with the spiders when my boy was 2 years old. And it moved on into the insect world. And I now enjoy nothing more than to have honeybees crawling on my hand. I just put my hand in front of my honeybee hive, and they all start landing on it and crawling on it. And it's an amazing pleasure and privilege to have an insect crawling on my hand now, whilst when I was a boy, it's something that really would put me off. So this is the start of my relationship with honeybees and the continuation of it. And now it's a real pleasure to witness them, to monitor them closely, to watch them, and to have them on my hands. It's an absolute pleasure. I love it now.
I think that journey is really interesting, from selling honey for lemonade money when you were a boy all the way up to holding spiders as an adult to try to impress your son, but also learn with your son. I think we all have similarly interesting journeys into the bee world. You've now found yourself as a faculty member at Nottingham Trent University. You do research with bees. When I was looking up some of your resume, I noticed that your research is not necessarily originally with entomology. You've got a lot of sound, vibratory work, which ultimately paired significantly with what we're actually going to talk to you about today. You guys just published this interesting manuscript, The Prediction of Swarming and Honeybee Colonies Using Vibrational Spectra. And the thing that's interesting to me is this manuscript really does two things. Number one, it introduces us to the topic of queens and their ability to communicate using sounds. And then secondarily, it teaches us about swarming and how to predict it. So I really want the rest of our interview to kind of focus on those two aspects. So to kind of kick this off, before we get to the swarming process and talk about what all of that means and how to predict it, I want you to talk a little bit, if you will, about what is a quack or a toot. You talk about that in the manuscript. The terms that I'm familiar with queens, is I'm familiar with piping. I've seen queens pipe many, many times. They'll, as you note in your manuscript, they press their thorax to the wax, and they make that sound, which is nearly
would
perfect.
Be able to do that.
Yeah, there's queens everywhere responding to me right now. But nevertheless, there's these other terms. I've even heard Tom Seeley and others talk about these quacks, these toots. So what is piping? What is quacking? What is tooting? And when is each done?
Do honeybees toot?
Not in the sense that you're asking, Amy.
Okay.
Oh, that's a very good question. We are actually presently trying to find a generic definition for what a pipe might be. So beekeepers and scientists have been using the word pipe for a long time. And when you start listening into bees and listening into the vibrations they make, you often will realize that they are incredibly short pulses, typically a tenth of a second, typically the time it takes for you to click your fingers. This is the kind of pulses honeybees and other insects most often deliver. However, in the case of honeybees, there can be instances of a longer pulse, perhaps half a second, perhaps 1 second long pulse, or perhaps in the case of the queen, many seconds, 6 to 15 to 20 seconds long vibration. And then I would say that this is what scientists and beekeeping start referring to as being a pipe. So a pipe is what you would hear as a sound, but it's actually a vibration produced by a bee, which is more than a snappy tenth of a second pulse. It's usually half a second to a second. So it goes boop, something like this, a tone for half a second to a second. That is a pipe. That's what we understand under the terminology pipe. Now there are worker pipes. So a worker bee can do a toot sound, but the most spectacular pipes come from the queen, and the queen can pipe for many, many seconds. And there are two different types of pipes that the queen can deliver. And the tooting is one of the two pipes, and the quacking is the second of the two pipes that the queen can deliver. Have I answered your question?
Absolutely. I think that's key to think about it. So a pipe is the general term for the vibratory noise that queens can make, and there are two types, the quack and the toot. So when do queens use them? How do they use them?
So most often, the toots and the quacks are heard immediately after the primary swarm. The primary swarm is your old queen, the queen that was fertile for the last year. She leaves your colony with half your bees. Most often, this is a silent phenomenon. There are no queen pipes associated with this phenomenon, except very, very occasionally. So we can come back to that later on in this chat. But when your old queen leaves, this is called the primary swarm, and this is usually a silent phenomenon not associated with any queen pipes whatsoever. And then you have a few days of silence in the colony, perhaps 6 to 7 days of silence, followed by the clear appearance of queen pipes coming from virgin queens that are that have either emerged from their queen cells, or they may be still locked inside their queen cells. The first virgin queen that emerges, we call these virgin queens the gynes, G-Y-N-E. The first one to emerge is tooting. She goes, ooh, 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 ooh. This is a tooting, and it comes from a free-roaming, free-running gyne queen, virgin queen, in your colony. And each time you hear this tooting, if you have other queens in your colony, they will respond by the quacking. And the quacking goes quack, 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 quack. Sometimes for up to 20 seconds, you will hear this response. And when you witness this and when you hear it, you will be convinced that it's a tooting that stimulates a quack as a response. Why? Because you get silence, then you get a toot, whoop, 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 after the silence, and immediately after the toot, you get the quack, the quacking. And then there's silence for a minute, and then another toot, and responded by quack. So there is definitely a human perception that it's queens communicating amongst each other, and there is definitely the perception that a tooting is a challenging call, which is responded by the quacking.
Let me ask quickly, Martin. I know Amy's got a question she wants to ask you, but this brings up a lot of questions that I'm intrigued by as a scientist.
I have so many questions.
Yeah, is a quack a toot that's heard from inside of a cell? I mean, are they truly different sounds, or are you just hearing a toot from a queen that's completely enclosed in a wax cell? And it'd be like asking, if I'm in the room with my wife and we're talking, that's one sound. But if I'm in this room and close the door, and now I'm talking to her through a closed door, she might be hearing a different sound. So, but are our quacks and toots absolutely different? Differences in frequency, differences in lengths of time and pattern and all that as well?
What a fantastic question. They are definitely different signals. In particular, the tooting is always a first long burst of 3 to 4 seconds of a continuous tone. Ooh, it starts with this. The quacking is never starting with this long pulse. The quack just goes quack, 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 quack.
Fascinating.
Quack.
That's fascinating.
So there is absolutely no doubt that they are different signals. Absolutely no doubt. And the most dominant difference is this long initial tone, which is taking place only in the tooting.
Wow, that's amazing. It's just incredible. And I just want to know how long it's taken you to practice that toot.
Yeah, I don't know who sounded better, is his or mine. Like, I feel like we should have a toot off at the colony and see if we can, he can do it, I can do it. We can see if Queens respond. Anyway, Amy,
toot off.
Toot off.
Well, I was about to say I must just not be in the industry long enough because I don't have a sound that I'm able to make like you guys can, but I'll definitely practice.
Try harder.
I think rather than being impressed by how long I practice, you would be most impressed by how many hours I have listened to this signal.
Well, on that note, can you tell us a little bit about how you guys conducted the experiment? I mean, I know that there's probably a lot that went into it, but just generally speaking for our audience, how did you guys go through this experiment to show this?
So what is unique to our measurement is that we are doing continuous recordings for colonies with no interruption. So we have written software on a simple computer, which allows us to record the vibrations continuously every second of the day, every day of the year for several years. So we have continuous acoustic log, vibrational log of colonies and of multiple colonies. So we have a complete overview of the occurrences of tooting and quacking in multiple colonies during the swarming season, before and after. So we are the only group in the world to have exhaustive recordings every second of the day, every day of the year, of these vibrational signals in multiple colonies. And from that, we ended up being in a very strong position to draw conclusions about the instances of these signals, when do they take place, under which circumstances, and how do they lock in the timings of the swarming, the primary swarm, the secondary, the tertiary, and so on and so forth.
What sort of equipment do you guys use to examine this?
So we assemble it. I am fortunate to come from a background that allows me to assemble equipment. I am actually a physicist. I'm not a beekeeper. I am not a honeybee scientist. I am not a biologist, but I can knock up equipment. This is what I've been trained to do. And we assemble the equipment ourselves. We purchase the vibration sensor separately from the amplifiers, from the computer. We write the software. So we assemble it all together. But forgive me, I've forgotten your question. What did you ask?
How you guys conducted the experiment. Oh, and what tools you guys used.
Okay, so we use a vibration sensor, which is in the colony. This is called an accelerometer. I'm sorry for the long word. It's a little cube which has no exposed surface, so you can plunge it into the honeycomb and it won't deteriorate the performance of the sensor. And there's a little cable that comes out of your hive. It goes to a sound card of a computer to log the vibrations, and then the computer records it. And we record it, and then we write software to examine the instances of the tooting and the quacking and lots of other signals coming from honeybees. So in a nutshell, that's how the method is.
Wow.
So that's a really great story. In fact, I think it's probably your background in physics and other things like that that allowed you to make these novel contributions. Oftentimes in the bee world, we kind of think about it from the bee perspective because that's all we've seen and done. But it helps to have people from who are not bee scientists to help unravel some of the mysteries of bees, I believe. So I want to read a quote from the manuscript that you guys wrote because I think it's appropriate as we transition from talking about quacking and tooting to talking about predicting swarms. And you say in the introduction of the manuscript, usually the primary swarm, that's the one that leads with the old queen. Usually the primary swarm is not preceded by piping. You've already stated that. But nevertheless, we've also endeavored in this study to carefully examine the pipes logged within our continuous vibrational data sets, which you just mentioned, as it seems to strongly support the theory that tooting and quacking are produced to inform the worker bees about the need to release or keep captive unemerged virgin queens. So for our listeners, that simply means that once the primary swarm is left with the old queen and she's taken 30 to 70% of the workers, the first virgin queen to emerge will go around tooting. The other virgins in their cells will quack. The workers will keep those virgins in those cells until that next swarm is issued. And that first virgin to emerge, when she leaves with that next swarm, there's the absence of tooting. Therefore, the workers can allow the next, quacking queens to emerge, as it were. So that's very fascinating. So let's transition then to how this brings some applied. You say in your study, you make the claim that you can predict swarming with over 90% accuracy just by listening for these specific sounds. Can you talk about that a little bit?
Yes. So in my job, the way this works in the UK, in the USA, and in most other countries is that we have an idea, we want to demonstrate it, and we seek for funding to allow us to run the study and do a professional job in demonstrating something. So this is how my profession works. And I had the idea to predict the swarming, and I knocked up a project to convince a funding body that we would prove that. Then we secured the funding, and then we ran the study. So in this process, I wrote entirely the project on the prediction of the primary swarm, the one which where we know is most often silent. So the primary swarm, again, is your first old queen. It's the first swarm you get in the spring, and it's the loss of your old queen, the one that was fertile. So it is a topic that is very exciting to beekeepers and to the industry, because it would be amazing to alleviate the need to inspect every colony to prevent that phenomenon. So we did get the funding on that basis. So it was the main thrust of the project, and we developed the methodology, we developed the study specifically to demonstrate our ability to pick up the preparation of the colony for the primary swarm. This was the big question. And then it took us many years to finalize the study and submit it. And when submitting it, I realized that there was a beautiful, unexpected add-on to our project. It was this spectacular collection of tooting and quacking that we also acquired unintentionally. And a beekeeper in England flagged up to me the possibility of drawing conclusions on the function of the tooting and quacking. So we crammed it into the same scientific publication, and I'm delighted we did, and I'm very proud of it. But it's actually an unexpected add-on to a study for which we got funding, which was entirely dedicated for the prediction of the primary swarm, the one that has no tooting or quacking associated with. And so, Jamie, I have forgotten the question you were asking me.
Yeah, it's not a problem at all. Basically, I was asking you, you make the claim that you can predict swarming with over 90% accuracy. So could you talk about how you discovered that part?
Okay, so we endeavored at making sure that we had the vibrational logs of multiple colonies before the primary swarm, during the primary swarm, and after the primary swarm. This was the main idea, was to use these and then inspect them afterwards to see whether we could collect a signature that takes place in the vibrations in the colonies, a signature that would be an indicator of the colony preparing for the primary swarm. And this is what we call a phenomenological study. So we have been seeking for a phenomenon. The phenomenon is the following. Is there a signature in the vibrational signals originating from a colony? Is there a signature revealing the preparation for the primary swarm? And so the paper is describing all our efforts to extract this signature. And we did it when we use a vibration that's just been measured for 3 minutes. And we do it also for a vibration that is taking into account the history of the vibration leading to where you are in the colony. So perhaps I could expand a little bit on this if you like. I don't know where you want me to take this.
No, absolutely. I think this is fascinating. I think beekeepers would benefit tremendously knowing that there's vibratory signaling prior to the swarm that you could use to actually predict when swarms will happen.
Okay, fantastic. So the idea has been raised many, many years ago. In fact, as long as in the book by Aristotle, so I think it's 300 years before Christ, the idea that honeybees' sound changes before the primary swarm has been suggested by Aristotle, believe it or not. And then it's been looked into by scientists. We are not the first ones to look into this idea. And so what our study, however, is pioneering is this extensive, continuous recording of the vibrations and the sounds taking place in a colony. And so we found that the vibrations that you get and the sounds and vibrations that you get in a colony can indicate the preparation for the swarming, but there is a big problem in the sounds and vibration in a colony. The big problem is the lack of specificity. I like to compare this with the blood pressure measurement in people. When I was a young boy, if the doctor was worried about your blood pressure, he would measure it at the clinic, and then he would draw conclusions about your blood pressure. This is completely not the case anymore. No doctor trusts a single measurement of your blood pressure anymore. Why? Because your blood pressure will vary enormously across the day. If you have too much coffee or alcohol or not enough of it, your blood pressure will go up and down accordingly, or if you have had a very stressful day or exciting day, and so on and so forth. So a single point measurement of your blood pressure is a very, very poor indicator of your blood pressure. If you want to know well whether you have a condition or not, you need multiple measurements at different times of the day, perhaps across several days. So we found the same with the vibrational measurements. We found that sounds and vibrations in a colony vary enormously across the day, across several days. And if it does reveal a preparation for swarming, it is not the case for a single measurement. So one of the things we claim in the paper, and we demonstrate it, is that you can't really draw conclusions from a single measurement. If you go to your bees, put your ear against them and listen to them, you will hear something that is a poor indicator, a poor specificity to what they're doing. So that was the first part of the paper. Sorry, did I interrupt?
No, I was just going to say, I'm thinking about everything you're telling me right now. And, I guess your normal beekeeper wouldn't be available to just listen or feel the vibrations or listen to the sounds, every day, constantly, all day, right? So I guess I'm trying to figure out what recommendations would you have for beekeepers as far as trying to, know when a swarm is about to happen or prevent swarms from happening? Because that's really what we're doing most of the time when we're managing bees.
Yeah. So one of the first conclusions of the paper is perhaps a little negative, if you like. We're saying Aristotle was wrong, or if he wasn't wrong, then he was overambitious with his statement. We think we have evidence that an instantaneous measurement of your bees, if you listen to the vibrations or the sounds, we think it's a poor indicator of their preparation for swarming. Even though it's true that the sound changes prior to the swarm, it's not going to be of much use. So what we're saying, however, just like for the blood pressure, is that if you look at the history of the measurement of the sounds for a few days before the swarm, then there seems to be a signature that is far more specific to the preparation for swarm. So provided you have a little memory device, a device capable of storing the history of a few days of vibrations and sounds in your colony, then we seem to be in a very strong position, 90% or so accuracy, to sense the preparation of the colony for swarming. So if you want to convey this to the beekeeper, I guess what we're saying is that don't trust a single instance of you listening to your bees. Don't trust that it's an indicator of anything specific that they're doing, because the sound and vibrations that a colony makes varies enormously across the day.
One of the things that you said in your paper too that I want to highlight is you mentioned the phrase precision apiculture. Now, I work at a university that does a lot of agriculture research, and in other fields of agriculture, they talk about precision agriculture all the time. But I've never heard the term precision apiculture. And we talk about sensing when a colony can swarm, et cetera. What do you mean by precision apiculture?
It means that the decisions that are taken by the beekeeper are assisted by measurements that man can't possibly undertake. So we suggest the idea that if a beekeeper, in addition to his or her skills, in addition to that, if they use devices to provide measurements, for example, with a memory of the history of the vibrations and sounds, etc., then you can improve the decision taking. You can make more accurate estimates of what's taking place in your colony because you are assisted by measurements you can't possibly undertake manually. So I think this is what is understood under this expression of precision apiculture. It's apiculture that is being assisted by modern equipment, providing the beekeeper with refined measurements of the activity of the colony that they can't possibly get by visual inspections or by listening.
Martin, I really love that idea. One of the things that I think is I feel like our industry has been relatively slow to embrace technology. Mm-hmm. When there's other commodities out there where there's, combines and tractors that are driving themselves based on GPS monitoring and things like that, yet we still pick up these boxes and lug them around the country for pollination. We still have to inspect thousands of colonies thoroughly to know what's going on. You make another statement that I'll kind of use to conclude. You mentioned in the introduction of the manuscript, with respect to the swarming process, if a system were in place that could identify a colony's intent to swarm, a beekeeper would benefit from being alerted to those hives preparing to swarm and would prioritize the appropriate swarm management procedures to those hives, reducing the need and burden for every colony to be regularly inspected, often unnecessarily. Here you're proposing to use sound to predict swarming. We know a lot of people are beginning to do work with temperature and CO2 and weight. I feel like there's so much opportunity for research in this area. That's why I really applaud the work that you guys published on this, just listening to the bees, interpreting these quacks and toots and using this information to make predictions about when colonies will swarm. It's really fascinating. So thank you so much for joining us on this podcast and explaining to our listeners.
My pleasure. Can I add a last sentence to this?
Oh, please do.
So I'm so glad you picked up that sentence because it took me a long time to appreciate the real help to the beekeeper. And not only did it take me a long time to appreciate it, but now that I use it for my own beekeeping practice, I can tell that it is the case. So unexpectedly, this precision apiculture business, I believe, is really helpful to the beekeeper unexpectedly by alleviating the need to inspect those colonies that will not swarm. So when I started this work, I thought, wow, it would be great for the beekeeper to know which colony is going to swarm because he's going to manage that swarming and he's going to intervene and help it. I've completely changed my mind. This is not the beauty of this work, in my opinion. And I benefit from it myself, as I said, because I do it myself. The big amazing advantage is that I am less stressed. I am far less stressed because those colonies I know who will not swarm, I leave them alone to do their honey, to do their business. And that is amazing drop of my own personal stress. Yeah.
So I want to ask one question that I don't have scripted, but do you think similar technology could be used to predict varroa loads or small hive beetle populations or nutrition stress, et cetera, in colonies? I know you look specifically at swarming, but there's these other management things we have to go into colonies to address. Do you think this same technology can be used to predict those?
Keep an eye on our publication. I think it's coming out next year. We have an amazing discovery with the varroa. So you mentioned the varroa infestation levels. This is something we've looked into. You will find one scientific paper by Quandor on the detection of varroa infestation level with acoustics. Unfortunately, the paper is not very convincing because they only have 2 colonies, one with varroa, one without. They show that the 2 sounds are different. It's not convincing that the difference is due to the varroa infestation level. But I have a PhD student who's dedicated herself for the last 2 years on the effect of varroa on our measurement, and we have some amazing news. Keep an eye on us. I very much hope.
You can't do that to
We'll
us.
have to have you back. Well, Martin, there's a scientist here in the U.S. who's also been working on sounds and vibrations for some years, and he's made similar predictions about varroa and beetles, and even potentially the subspecies of bee that we're dealing with, whether it's European descent or African descent. So to make a long story short, I have no reservations at all believing that, this precision apiculture using technologies like this are going to go a long way to helping beekeepers in the future. I think it's great that scientists like you, I look at your specific manuscript, it's got a large author team. So there's a lot of individuals involved, no doubt students and colleagues, et cetera. So I'm happy to see that people are heading in this direction. For our beekeeper listeners, you just need to know that these technologies are coming. They may not be here today, but they're coming and they should make your beekeeping easier. Martin, thank you so much for joining us on Two Bees in a Podcast. Absolutely.
Thank you, Jamie. Thank you, Amy.
Sure. So folks, you've been listening to Dr. Martin Binchik, the Associate Professor at the School of Science and Technology at Nottingham Trent University. Again, in our show notes, you'll be able to see a link to the paper that thoroughly covers all the topics that we've discussed with Martin in this interview. Thank you so much for listening to Two Bees in a Podcast.
Have questions or comments? Don't forget to like and follow us on Facebook, Instagram, and Twitter at UF Honeybee Lab.
So, Amy, I've got a trivia question for you.
I'm not good at trivia. What is it?
It's really simple. Do you know how long I've been working at the University of Florida?
Let's see. You started in 2006, right? And it's 2020, right? That would probably be 14 years.
Yeah, this.
Did I do the math right?
Yeah, you did. For the benefit of the listener, it's June 2020, and August 6th, 2020 is my 14-year anniversary, which is hard to believe it's been 14 years, but it has been. And the reason, Amy, I'm asking you that because before there was Jamie at the University of Florida, I had a predecessor who blazed a trail with honeybee extension as well. And it is my pleasure to be introducing him and you and I interviewing him on today's Two Bees in a Podcast. That individual is Dr. Malcolm Sanford. He is a professor emeritus in the entomology and nematology department here at the University of Florida. Malcolm, welcome to Two Bees in a Podcast.
Well, thank you so much. I appreciate the invitation, and I'm glad that I was the predecessor of you. And you're the guy. You're cool. The guy now that does it. All the stuff. I got.
So if you're my predecessor, does that make you?
I can sit back and relax.
Does that make you my ancestor? Are you my academic ancestor?
I was just on Ancestry.com, but I didn't see you there. For me.
Yeah, we're probably not related, but academically we are at least. So Malcolm, you had the job here at the University of Florida before me. We're going to get into a lot of that, but before we get there, could you kind of briefly tell us your story? how did you arrive at the University of Florida in the first place? How did you get involved with bees? What steps brought you here?
Okay, well, I've got a kind of a long history of sorts. I was in the Peace Corps back in the 60s. And then back in 1966, I got out of the Peace Corps and I went to the American Institute for Foreign Trade at that time, an international business organization. And then it was 1968, and I was draftable, potentially draftable at that time for the Vietnam conflict. And so I went down into Phoenix, Arizona. That's where I lived at the time. I went downtown and I joined the Navy. I joined the aviation part of the Navy. I thought, well, I got to do something. And I had a friend who was a Marine, and he was in the Marine aviation. So I went down there and joined the Navy. And I went to a little bit of time. I went through officer training school. Then I went a little bit of time as pilot training over at Pensacola. I didn't like that. It really didn't. It didn't really. I wasn't really a flyer much. So
but before you go any further, you can fly an airplane. You were trained to do that? I mean, this is news
Maybe
to me.
That's why he didn't continue, because he couldn't fly an airplane.
He's talking to us, so he didn't crash an airplane at least. So.
Well, no, I can't. I mean, I quit before I became a pilot.
Oh, okay. So
okay. When I quit, right. It was just too much of an investment of my time, because I would have had, 2 years of training in flight school. And then I would have set 5 years of being in the fleet for piloting. That had been 10 years out of my life. I just couldn't do it. So I quit. And I went, and so they sent me to, I was in the aviation branch of the Navy. That's the Brown Shoe Navy. And so I was sent to California as basically I was a desk guy, a desk jockey. I was an administrative officer. And from that, in 1969, we went to Vietnam on the USS Ticonderoga, a CVA-14 at the time, and we did what was called we were stationed off a Yankee station. We bombed North Vietnam for 6 months. When I came back home, that was the last deployment of that ship. And then when I started to come home, the war started to wind down. And so I got back kind of at the right time when I got out, just after the war was over. So then what was I going to do? Well, I went home. My folks were in Georgia, so I went to the university. I didn't go to the University of Georgia at the time, but I went home and I worked around, looked for things, and finally I went to the University of Georgia.
Yes, you did. Go Dogs.
That's right. You're right.
Always, it all comes back to the University of Georgia.
Between the hedges, baby.
Just thought I'd say that. Thank you.
Yeah, I forgot. Yeah, I'm a little bit, problematic because I'm not much of a Gator fan, Frank. I'm not so much of a football fan generally. Sorry.
That's fair.
Well, let me tell you my football history. I was first hired.
Were you the quarterback for the University of Georgia, since you also learned how to fly airplanes?
No,
you're going to pull out of your hat, Malcolm.
All right, I'll tell you about it as we go along here. So anyway, so I went to the University of Georgia. Because I was involved in Latin America in the Peace Corps, and I speak Spanish, and I like Latin America, and I visited down there, and all the rest of it. I studied geography, Latin American geography, at the University of Georgia. And in my situation, I was going to had to develop a thesis, a kind of a concept of what I was going to do. What kind of geography can you do? And so I got this idea. My father was a fisherman way back when. I got this idea that I could go down to Latin America. I could study the fishing industry. So I proposed that topic to my boss at the time, and he says, "Okay, fine." And I actually got a grant ready from the U.S. Steel Corporation to go down to Yucatan Peninsula and study fishing, the fishing techniques. And before I did that, I took a course in beekeeping from Dr. at that time from
was it Georgia? Was it Al Dietz?
Yes, that's exactly right. Thank you.
Well, you're very welcome.
Well, I'm liable to have some senior moments.
That's okay. I'm liable to have some junior
That's
moments.
one of them, yeah. Anyway, yeah, Al, and so then I took from Al Dietz the geography, the beekeeping thing. And then I went down and my young wife and I at the time, we drove down to Yucatan from Athens, Georgia.
Really? Gosh.
Yeah, right. And so when I got down there, though, and before, I found out that really there wasn't much data about fishing. I didn't have any in with the fishing industry. I knew nothing about what was going on. There was no real industry anyway. It was just a bunch of guys, fishing with nets and so on, and individual basis. But when I got to Yucatan, what did I find?
Let me guess, bees.
Bees. That's right. At that time, the Yucatan Peninsula was the largest honey production unit in the world, and most of that honey was going to New York City and was being purchased by a guy by the name of R.B. Wilson Company. And so when Yucatan at that time, there were cooperatives, there was people doing all kinds of things with bees and all that. And so I switched from fishing, I switched to bees. And so I had a good time down there. I spent a lot of time, and I talked to people, and I wrote a thesis on that. And then I came back, and then I went and tried to do something else. I thought, well, I'm still interested in academics, and all of a sudden I'm interested in bees. Why? I got bee fever. I guess you.
Why do you sound so surprised? I mean, bees are very addictive. That's what's funny. The whole irony in this story is that you meant to go get hooked by fish, but you got hooked by bees.
That's right. And again, bee fever is something that comes on people. It's kind of like the COVID virus, it's out there.
Well played,
all
Malcolm.
the time. You're liable to catch it at any moment. And so I said, okay, well, hey, I'd go to entomology. So I went over there and I got a job. Al Dietz gave me a job in the lab to raise queens and do all kinds of great stuff with bees and so on. And I spent, a couple, 3 years there. And then he after just as I graduated, he left on a sabbatical, and I became the professor of apiculture at the University of Georgia for a short time before I was hired at the Ohio State University as extension specialist in beekeeping at that time, set in 1978. I think it was, 78. And the guy that hired me was Walter Rothenbuehler.
Wow, that's really neat.
Yeah. Now Amy probably doesn't know who Walter Rothenbuehler is, but if you look at my stuff, you'll see what he is. He was the guy for beekeeping research in terms of breeding honeybees and so on. He was the guy, and so I was really proud to be an extension guy under him for a while. And then all of a sudden, a job came up at the University of Florida. And so I applied to that, and I was all of a sudden hired at the University of Florida.
What year was that, Malcolm?
What year was that?
Yep. What year was that?
81.
1981.
So Malcolm, we're about to get into your career here at the University of Florida. Okay. That's what the rest of our questions are. But before I get there, with your varied background and the fact that you're retired now, I'm just curious if you could briefly list what some of your hobbies are. What do you do now when you're not working with bees?
Oh, what I am is an actor. So, and of course anybody, and you are one too, anybody that's involved in extension or teaching or academics, you got to become an actor. I mean, that's the way it is.
We're all actors. This is our fake personalities, our radio.
That's right. We're much nicer in real life, aren't we?
Oh, yeah, right.
Something like that.
So that's part of what I am beyond, but I'm really a writer. And the thing I'm most proud about in terms of writing are my 2 books. I've got 2 books that I've written. One is a Story's Guide to Keeping Honeybees, which is really a good seller, and I'm very lucky to be involved with a publication outfit that is not involved in bees, and that means that they have an incredible reach for selling this particular information because they're not involved with bees; they're involved with everybody else. So
that's right. I'm
very happy to be there. And then in 2006, I wrote a book called Beekeeping Without Borders. And that book, published by in the UK at the moment, Northern Bee Books, is a history of my 2 sabbaticals during my career at the University of Florida.
So
1989.
Malcolm, we'll make a point to link both of those books in our show notes on our website
Great.
for Two Bees in a
Okay.
Podcast so that our listeners can find them there.
Wonderful. Okay. And 1989, I was in Italy. And in 1997, I was in France for 6 months.
Awesome. So, okay, so you're an actor, you like to write, and that is a lot of what we do in extension sometimes, and just communicating through writing, through, I guess, acting, right, when you're teaching in front of an audience
exactly.
and on a stage. And so my question to you is, what were your primary extension, what was your primary extension focus when you were at the Honeybee Lab? Were you familiar with extension before that, or, were you kind of just learning along the way?
Yeah, I learned along the way. I was never a researcher. I was always an actor.
That's fair.
So I really, when I became an academic, I became an extension specialist. And so, and that's that. So I'm not a researcher. I don't have any research focus. I'm the guy who goes out and tries to find people doing research and tell the public what the hell they're doing and how it should. I'm a translator in a way.
Sure.
I'm a translator too because I speak Spanish and I can, in English, and so I translate between Spanish and English, just like I translate if you talk to people between bees and the other world.
So at the time that you were in extension, you were hired on as 100% extension.
100% extension at that time. Probably the last guy to be hired at that rate. I don't know, but after I was there for a while, it became obvious that 100% extension doesn't exist anymore.
Yeah, well, I'm 100% extension.
Well, then it does exist.
He's mainly talking about the faculty.
That's true. That's true.
Well, you're right, Malcolm. You're right. Most. I'm trying to think about this. I'm actually 70% extension, and that's probably the largest extension appointment of any faculty members I know. And most faculty members are 50% or below, and in fact, probably most have 0 to no extension appointments. So
now I have a new goal. I have a new goal for you. Malcolm, how many beekeepers were in the area? How many beekeepers were you working with when you were in extension?
Well, that's a good question. I wasn't, not only was I an extension guy, but I was involved in international stuff. So yes, I was Florida extension specialist, but I was also, and the thing what I'm really kind of proud about is I was the guy who was the international representative for beekeeping extension in the United States for the whole career that I was existed in, which means I went around the world and talked to people about bees in their own language and all the rest of it in a lot of different areas. And that was my, you want to call it my focus. That would have been my focus at that time. And there was no UF Honeybee Lab, of course. There was only me. There was no money. That's the other aspect of it. Jamie came and he got all the money. But before me, there was no money.
Well, Malcolm, you're actually raising an interesting point. I was hired in 2006, which is when, quote, colony collapse disorder was first discovered. But you mentioned being in there in 81, and there were a couple decades scattered through there where bee research, bee extension, et cetera, was kind of dwindling. In fact, I was told at the time that it was possible that UF's position might be the last true bee scientist position that comes around. And of course, CCD happened and everybody and their brothers opening a bee program at universities all around the world. But you're right, during your time, there was less funding for bees, less emphasis on bees, which is odd given that, you were hired in 81, but 87 was when Varroa was found in the US, right? So you had a really big thing happen while you were serving on the faculty here at the University of Florida.
I had 3 big things happen.
All right. What were they?
First one was the arrival of the tracheal mite in 1984. Then the arrival of the Varroa mite in 1987.
Mm-hmm.
Then the arrival of the small hive beetle in 1996.
Wait, did you introduce all these things, Malcolm, from your travels? I feel like there's a...
Yeah, so I went through three real critical kinds of developments during my career at the university, and they were, informed by those particular things. And then what happened, of course, to the industry before when I started as a extension guy, the primary industries in Florida were making honey of creating honey and selling it, and creating bees and queens, rearing queens and package bees. Well, 1984 came, and most of the packages were sold at that time, and when I got there in 81, were sold to Canada. Well, why was that? Well, the Canadians had this wonderful area up there for making honey during the summer, but boy, you didn't want to winter bees in Canada. So what became an issue is they killed all the bees in Canada, and they bought new bees every year from Georgia and Florida, Mississippi, and all across the southern states. And that was their business model until, guess what? They closed the border in 1984. Tracheal mites came, and that finished the whole thing.
Wow. Well, let's kind of dive into that. Amy has asked you what was your primary extension focus while at UF. I'm curious, what are some of your main extension accomplishments while you were here at the University of Florida? I mean, I know what some of them were, but tell us a little bit about your programs, your newsletter, your institute, things like that.
Yeah, well, there were two things basically that at the time I was hired were the big deals here. One was that was called the Beekeepers Institute. That was like the first sort of bee college, idea. It wasn't a bee college. It was a summer camp. That's really what it was. And so around the state, I was responsible for developing every year some kind of an academic venue and some kind of a program to entertain and teach beekeepers for a particular week, generally in August in Florida. And
wow, you sure picked the hottest month.
Well,
Seriously.
Well, I didn't pick it. This was all picked for me. It's like okay. I just stepped into it, and there I was. So
okay.
So that was a particular focus of mine. The other thing is because I told you I'm a writer, so I started my newsletter back when I was in Ohio, and then I continued my newsletter when I got to Florida. And my newsletter, at this point, at that point, when I retired, it had about 3,000 people on the list. It wasn't
That's
just
great.
Floridians, it was other people.
What did you put on the newsletter?
Everything. I was a reporter. It's like, okay, this is what's happening here. This is what's going on here. This is where we're doing this, and et cetera, et cetera, et cetera.
Now, Malcolm, those are still archived on your website, are they?
I've been that for 30 years. You can you can see all my stuff for 30 years on the website.
Okay, well, we'll make sure and link that in the show notes again for the listeners.
Right. So that was my charge at the time, and then I did other things. There was the state association. I was involved with that. And there were other kinds of things that come up. I did a feeding study as part of an actual research study on what was called at that time the Beltsville bee diet. It was a kind of an interesting diet developed at the Beltsville Bee Lab, and I was one of the first people to do that, or try to do that. I didn't do it very well, and the reason I didn't, which I realized afterwards, was it was partly my fault, but it was also partly the fault of the design, because it had to do with beekeepers. So we brought this food in from Beltsville and said, okay, beekeepers, here's what we want you to do. We want you to feed this stuff to bees and give us a report about what it's doing. Is it working? Is it not, according to your observations? Now, these beekeepers that I started out with, the guys were in the Panhandle. Of course, I lived in Central Florida, so I wasn't out there every day out in the field. But I go over there once in a while and say, well, how are you doing? What's with this thing? We had a whole research protocol, me and a guy who was a bee inspector at the time. And so over time, I realized, I'm not getting the information from these guys. We've got a plan. We told them what to do. What's going on? So I was in a truck with a guy one day. I said, what is happening here? Where's your report? And he says, what do you mean report? Well, I said, we're giving you this food. We expect you to have some kind of a research report. Where is it? He says, well, I don't know. Well, it turned out it was under the seat of his truck.
He never used it.
He never used it. Yeah. So basically, there was no data to come out of that much. You could talk about things, but it really wasn't very significant because obviously you can't have significance if you don't have any data. And so it kind of blew up. But that was my one and only real actual research.
It can be, you're raising an interesting point that's kind of worth mentioning, and I don't want to chase this rabbit too much, but when we do research, we have, usually two options: to manage the colonies ourselves or to work with beekeepers, and both systems have drawbacks to them.
Yeah,
but you're definitely mentioned, potentially one of the drawbacks of working with beekeepers. We know a lot of you beekeepers out there. Don't panic. This isn't intended to be mean, but it can be difficult because beekeepers have management systems that they have to live by and work by, et cetera. And so sometimes it's hard to fit in the rigidity of a research project into the system that they're trying to follow. So I can certainly sympathize with what you're saying, Malcolm.
Well, if you look at the first thing that I heard, one of the first articles on my new website, beekeep.info, you'll see a title there, What Beekeepers and Researchers Want. And it goes deeply into this area we're talking about there.
I feel like, we're definitely going to have to share that. But I think it's so funny that Jamie asked about extension accomplishments, and Malcolm, told us one of his fails that he had, which it wasn't all you, but it's just so funny because those stories always, they last with us forever.
They come up.
They never go away. So Malcolm, it sounds like you were working primarily with beekeepers. It sounds like you were traveling, talking about bees, I assume, to non-beekeepers as well. And so obviously you had to teach, but I'm wondering, did you have to teach for undergraduate students or have grad students as a faculty member? Even if you were hired on as 100% extension, did you do teaching and have courses? I
did do teaching. I taught the introductory bee class. And then after the end of my career, I was teaching the introductory entomology class. And so I definitely I had one graduate student. That was
great.
It. And he didn't make it through. So, well, he had some problems and so on. And so I finally realized, well, this guy just isn't going to make it. So we parted company. But that was the only graduate student I had.
Yeah. Were your beekeeping classes, were those in person?
Oh, yeah.
They were all in person, right?
Oh, yeah. I was the actor. I got to get in there and get acting.
Yeah, that's fair.
Got up in front of standard stuff. And so was introductory entomology the same way. Insects are just absolutely incredible organisms, and honeybee just one of them. I love insects all around. That's one of the things I'm in this co-housing complex over here, and every quarter, guess who shows up? Florida Pest Control.
Oh, there you go. I was the tax man.
The big flag in. They got a plastic thing they stick on the lawn. Don't walk here. Pesticides are being applied. They run around and I'm going, what in the what? Why? Well, the problem is I live with people who can't stand insects. They don't even want to see a single one around. And so I'm just stuck with that mindset. But for me, it's just crazy.
Well, Malcolm, let me get you to think back about your career that spanned 3 decades, kind of here. So when you were here at UF, over the 2 decades that you were here, what are some of the significant changes that you saw in your time working with Extension? You already talked about the introduction of tracheomites, the introduction of varroa, the introduction of small hive beetles. So clearly these have had substantial impacts on the industry and have brought about a lot of changes, not only here in the U.S., but around the world. But what are some other things that you feel like you've noticed change over the years while you were a faculty member and even since then?
Well, yeah, if you look at have you seen my my Opus video that Umberto developed?
I did, yes. Mm-hmm.
Well, that basically covers, what a lot of what I saw even after my career was over. And of course, the big thing is the incredible shift from being honey producers to being pollinators. The industry, became a pollinating industry instead of a honey production industry.
That's pretty cool. Yeah.
And all the stuff that was involved in that, and still going on. And of course, varroa and all these other kind of organisms, you had to be always on the lookout for the next fix, the next pesticide or the next way to do something to, keep these things at bay. And so that was part of it as well. These shifts that are going on, they're continuing to go on. I'm still involved in some of that.
So Malcolm, what were some of your favorite moments during your career?
Well, that's a good question. I specific moments. I met a lot of great people in beekeeping. I went to a lot of meetings and a lot of international meetings. And so, I became, as I said, I was kind of the international outreach for Beekeeping Extension at that time.
Mm-hmm.
So I knew Italians, I knew French people, I knew, Spanish people, I knew people in Latin America. I mean, on and on and on. So possibly my biggest thing really at the moment that you can look back on are these two books that I wrote and my 30-year, and I'm still doing the newsletter, as a matter of fact. I've shifted a little bit to a kind of a cost you $1 right now. If you want to get my newsletter, it costs you $1. Can you afford $1 or not? Well, 30 people have said they could. So I'm writing a newsletter now for 30 people for $1 a piece. Well, yeah, it's kind of a hobby for me right now. Sure. And that may go away. It's hard to know exactly, but that's those are that. But the shifts that have occurred have all been, again, that kind of magnitude. That went from something really high to something really low. So that's kind of been, that was my kind of been my, at that time, that answered your question.
Yeah, Malcolm, you mentioned some things that I think too about my own career is I've also been to a lot of meetings and met a lot of beekeepers, not only in the U.S., but around the world. And that's always one of the most rewarding parts is to see how, they live, how they keep bees, what the issues are that they face, and, just how they're people like everyone else, and the struggles that they have and the successes they have. It's always
that's right. That's
kind of
exactly
rewarding
right.
to see that.
Yeah. And then that's one of the really interesting things about the bee industry, if you want to call it an industry, and that's, or the beekeeping, the activity of bees is that every place you go, there are beekeeper societies and there are people that are asking the same questions. If you're in Slovenia, you get the same questions as if you're in the United States. So
that's right.
Same
that's right.
idea. Yeah.
Well, Malcolm, let me ask kind of this final question with all that you've done and all that you've accomplished, all that you've seen and been a part of over the year. What do you kind of consider your legacy contribution just to the University of Florida in general, but also the beekeeping industry? What are you most proud of having done and that you believe has made the most impact for the beekeeping?
Well, I hope it's my publication record. I've not just written a newsletter. I've written for the Beekeeping Press for 30 years too. And so Bee Culture Magazine, American Bee Culture, Bee Business when it was available. I mean, all kinds of things like that. So really, it would have to be my, in kind of summary, my publication record.
Yeah, it sounds like you had a huge influence and you're pretty active, as far as having your fingers in lots of things around the world. That's great.
Well, again, and one of the problems there is, I says it's a problem, but one of the issues there is how do you measure your impact?
Yeah, that's a question Jamie and I ask each other every day.
I'm sure it is. And that's the educator. That's the educator's dilemma. You go out there and you develop something and you think it's important and you deliver it. And then how do you judge, your effectiveness in terms of whether it was understood and are people actually doing it?
Well, Malcolm, my guess is that your generation, the academics that were, retiring maybe in the early 2000s, your generation is the one that really went through some fundamental paradigm shifts in the beekeeping industry. Varroa was big. The change from a focus on honey production to the change of a focus on pollination is big. There's been an explosive growth of beekeepers even recently. All of that training you did for hundreds, probably thousands of beekeepers, all of the individuals who would have read all your written works, attended a Malcolm Sanford presentation, et cetera, they benefited and it really paved the way for what we are having to do today in our own programs, right? I inherited the position that you had here at the University of Florida. So, a lot of your legacy continues on. I know when I travel a lot, I hear a lot of people refer to you and mention you even when I'm going nationally or internationally. So everyone, as we wind down our interview with Malcolm Sanford, he's already mentioned earlier that one of his hobbies is acting. He's in a lot of play productions. You can see all that on his bio link that we'll include in the show notes. But in there, he's had to put some songs that he's recorded. I'm assuming, Malcolm, you had to do that to show off your vocal range for the plays that you were hoping to be a part of. But you recorded one specifically about honeybees. Could you tell us just briefly about that? Because what we're going to do is, as we're kind of fading out of this segment of Two Bees in a Podcast, we're going to play an excerpt from your song. So tell me all about that song.
What's the name of the song?
It's the one about honeybee, be my lover, or something like that. I listened to it recently. It's been going through. I even let my kids listen to it. And they've been humming it around the house. So it's honeybee, honey something, be my girl, or something.
Yeah, there you go. Okay.
Tell me all about it, Malcolm.
Honeycomb.
Honeycomb. That's it. Honeycomb. Listeners, you're going to be able to hear it again as we fade out of this.
And it is me singing. It's not the other guy.
Wait, that's you singing in it, Malcolm?
That is me singing.
Oh my goodness. I had no idea. That is so funny.
No, it's not me. So Malcolm, I think our listeners are going to really, it's going to put the icing on this.
There you go. All right.
So I just want to say thanks for joining us on Two Bees in a Podcast. I want to thank you for all that you've done. And again, we're going to link as much as we can about you and your books, your website, et cetera, in our show notes today. So if anybody wants to hear more or read more, they can do that as well. So Malcolm, thank you so much for joining us.
Well, I appreciate very much the opportunity, and take a look at my videos that Umberto did. I think those are important things to take a look at.
All right, absolutely. And guys, what he's referring to is Dr. Umberto Boncristiani here in our laboratory has an inside Hive TV's series that he has on YouTube. And so he interviewed Malcolm, and we can make sure and link that in our show notes as well. Everybody, that was Dr. Malcolm Sanford, who's Professor Emeritus of the Entomology and Hematology Department here at the University of Florida. He was my predecessor. So thank you guys for listening to this segment on Two Bees in a Podcast.
Looking for a home. And they called it honeycomb. And they roamed the world, and they gathered all of the honeycomb into one sweet ball. And the honeycomb from a million trips made my baby's lips. Oh, honeycomb, won't you be my baby? Well, honeycomb, be my own. Got a hank of hair and a piece of bone. I made a walking, talking honeycomb. Well, honeycomb, won't you be my baby? Well, honeycomb, be my own. What a darn good life when you've got a wife like honeycomb. Honeycomb. And the Lord said, now that I made a bee, I'm gonna look all around for a green, green tree. And I made a little tree, and I guess...
Okay, and we're back for the question and answer segment. Jamie, you've got 3 questions. You've got a couple of answers.
18 answers, probably.
Took you a little bit to figure out how many answers you had. 18. That's
well,
fine.
I'm sure it's going to be 18. I want you to count me as I'm trying to answer the questions that you asked.
Okay. I don't have 18 fingers, though, so I don't know how to do that.
Well,
all right.
Neither do I. Is that common?
I don't know. So the first question we have, what does it mean when beekeepers are treatment free? I hear this all the time that people are using natural beekeeping practices. And I mean, honestly, I guess I have that question too. What does that actually mean?
I was about to say, Amy, that it means their bees are dying, but I know that we'd get a lot of hate mail if I said that.
We might.
Yeah, no, in all seriousness, there is a huge range of what that means to beekeepers. There's no formal definition, but generally what it means is that they're staying away from the synthetic treatments for the various diseases or pests. For example, they won't use antibiotics to control European foul brood or respond to American foul brood. They won't use Apiguard, or they won't use Apivar, or they won't use, Checkmite or Apistan to control Varroa. They won't use Checkmite for small hive beetles, et cetera. The idea is that they're using a lot of more natural things to try to address bee issues. They might be investing in resistant stock, VSH queens or hygienic queens or New World cardiolans or Russian honeybee queens. They might be using things such as screen bottom boards. It's important to know that there is a distinction between natural beekeeping and treatment-free beekeeping, because natural beekeeping, and again, this one also has a sliding definition, but natural beekeeping most commonly means you let the bees do what the bees do. Mm-hmm. And you just kind of step back and maybe here and there try to facilitate what it is that they do. And to give you an example, a lot of purist natural beekeepers, they allow their colonies to swarm. It's just a natural part of the bee life cycle. So why should we stop that is kind of the premise. So what you'll see in natural beekeeping is things like that. They might keep bees in smaller hive boxes, et cetera. But there is a growing movement towards this. I've seen treatment-free and natural beekeeping seminars and symposia popping up all around the world. But it's this idea that we are going to try to keep bees the way the bees want to be kept. More hands-off, fewer chemicals, fewer acaricides, fewer or less management strategies. And the idea is that if bees are allowed to do what they do best, then they don't need so much intervention from us. I will tell you, like I've told thousands of people who ask me these questions, I have no problem with people keeping bees the way that they want to. But I will tell you, again, this might get some hate mail, that this often produces populations of bees that have very high mite loads or other disease and pest loads. And there's been no good research on this, so I'm not saying that this is a problem, but I will tell you a lot of commercial or even sideline beekeepers believe that a lot of their problems might be harbored in high numbers in these kind of treatment-free beekeepers who say, I'm going to just let my bees do what they want to and the best survive, et cetera. Well, that can promote high populations of varroa and other things. So there's this kind of battle between the two groups at the moment. And what I would say is the jury's still out. There's just not a lot of data. But I will say that my official opinion is that as beekeepers, is we have responsibilities to manage the diseases and pests that bees might otherwise struggle to manage. So I have no problem doing what it takes within the realm of what's legal to control diseases and pests. But that's a big umbrella overview of something really hard to define at the moment. It's a bit amorphous.
Yeah, I feel like we could have a whole segment on it, actually.
In fact, we should, Amy.
Yeah.
I think it would be really good to bring in some people who are treatment-free or people who consider themselves natural beekeepers.
Mm-hmm.
But I know Tom Seeley has written very recently about Darwinian beekeeping and this idea. He's got, I think, 10
Darwinian.
Darwinian. Yeah, sorry. I don't know. It's such a new term. It's how you want to say it's how it can be said, but Darwinian beekeeping, this idea, I think he's got like kind of a 10 commandments that he's put out based on all of his years of research, the size of colonies, how spaced the colony should be, and all of this Darwinian beekeeping. So the idea is that, it's growing, and maybe he'd be a good person to interview about this, but I can tell you, Amy, it's a hot button topic because both sides of the coin. See, you've got my tongue tied. Both sides of the coin, believe themselves to be adamantly right, and they both often scream at the other. And the truth is probably it's somewhere in the middle, and it certainly needs to be explored further.
That's fair. It is lunchtime, so you're probably thinking about corn. Okay, let's go to the next question.
No, it's always lunchtime though in my world.
So the second question we have is Amdro safe to use around the hives? What is Amdro?
Oh, so Amdro is a ant control agent, and I always answer questions like this when I have problems with ants around my hives that some of the other ant control strategies aren't working. Then I use Amdro around hives or products like it. So that's not an endorsement. It just is me saying that I've considered it safe enough to use around the hive to actually use it myself. I will give you an example. My wife actually did her PhD work at the University of Georgia, and she had a tremendous fire ant problem around a lot of her research colonies. So we actually put out products like Amdro around the hive and never noticed any negative effects on our bees. So some people are concerned because Amdro specifically are these kind of yellow granule type things that look like pollen pellets. So the concern is bees might pick it up like pollen and take it to the hives. I just never saw that. Now, you could argue that if bees are on the ground and being exposed to this stuff around the hives, it could be an issue. I just never saw populations of bees go back when we were using this, but I did see the population of ants go back. So it seemed to be helpful in our very specific scenario.
Okay. Talking about bees and the decline in population numbers, this leads to my last question for you is, I've had calls from people who will see one or two dead bees on the ground. And so my question is, how many dead bees is enough to actually be concerned? Are we worried about a couple of bees?
Well, that's really a great question. You know, people panic and freak out about everything in the bee world. Me too, when I was a brand new beekeeper. You know, it goes back to the small hive beetle questions that we've had in the past. You know, people open the lid of a colony and see a small hive beetle and want to throw everything they can in that colony to try to stop the beetle.
Yeah.
And likewise, you just asked me about ants, you know, around the hive, and we talked about the use of Amdro or similar products. Just because I see an ant, maybe I've got to go out and treat around. Well, my question is do you really have a problem that warrants treatment? Now you're asking specifically, well, what about dead bees? How many is too many? Well, if you think about it practically, a beehive can have 40,000 individual worker bees, and they're all alive. And what do we know about things that live?
They die.
They're going to die. Yeah, exactly. So if you've got a 40,000 bee colony, you're going to see dead bees outside the hive. That's just a fact of life. These things are going to die. Every one of them is going to die, you know, in 6 to 8 weeks, and their bodies are going to have to go somewhere. Generally speaking, bees are pretty good at hauling off their dead. You know, they'll fly them some meters away from the hive, 10, 15, 20, 40 meters away from the hive. So usually around my hives, I'll only see 15 to 100 dead bees or decaying carcasses. I would argue that when you start seeing piles of bees where bee bodies are accumulating, 50 to 100, it warrants looking in the hive to see what's going on. But if everything in the hive is otherwise normal, you've got a laying queen, this brood pattern is solid, you've got a population of bees representative or appropriate for that time of year, then I wouldn't be too concerned. I've had situations where I've had 100 dead bees in front of my hive and not be worried at all. But I've had situations where I've had 100 dead bees in front of my hive and been scared to death because I've looked in the hive and see what's happening.
Sure.
I think it's a bigger issue if you see a lot of crawling bees on the ground outside around the hive, 10, 15 or more, or if you're starting to see piles of bees, 50 or 100, then you'll want to go in the hive and determine, am I seeing something in this hive about this colony that gives me concern and gives me reason to believe that pile of bees outside the hive is a problem? Or am I seeing things that are absolutely okay, strong populous, life looks good, now all of a sudden that little pile of 50 to 100 bees is not a problem? So look for wandering bees, look for that accumulating pile of bees, and that should be a trigger to go into the hive. But it's possible to see both of those things and get into the hive and still say, you know what, things still look good. It's not
and I was also going to say, so when I was living up in Virginia and beekeeping, we had something called winter, which we don't really have here in Florida. And, you know, that was, so we would have we would have 2 feet of snow, and the snow would go and, you know, hit the entrance. And of course, once it started to warm up, that was just the hygienic behavior of bees tossing dead bodies out, right? So that's totally normal. So some of this could be normal as well.
Yeah, it could be, but I will tell you, Amy, by the time I'm seeing 150, 200 bees, I mean, that does start to trigger me to say, okay, even if things look normal in the hive, that's still a pile. And then I'll tell you a couple of reasons for this. Number one, the bee should be carrying off the body, so I shouldn't be seeing a whole lot. And number two, when bees that are deposited outside the hive, you know, there's ants and all kind of stuff that very quickly take out those bodies. So if I'm starting to see 100, 150, you know, bees pile up, then there's a problem with the undertakers who are hauling off those bodies, or their bees are dying at a rate that's faster than the ants themselves can eat it. And so those things kind of give me pause for alarm. Certainly, if I'm seeing 1,000 bees or more, then I have reason to believe that there's massive die-offs and significant problems. So like I said, to just summarize my statement, if I'm seeing 10 or 15 living bees wandering on the ground outside the hive, I'm going to go in that hive and figure out what's going on. If I see 50 to 100 dead bodies outside the hive, I'm going to go in that hive and see what's going on in the colony.
Great. All right. Thank you for that.
My pleasure.
So everyone, thank you so much for your question and answers. Thank you so much for your questions. Jamie, thank you so much for your answers. If you guys have more questions, please feel free to email us. I know people have been emailing or messaging me on Facebook or Instagram on our Honeybee page. And of course, if you do like the podcast, don't forget to go to your podcast app and rate us if possible. That would be great. Hi, everyone. Thank you so much for listening to this week's episode of Two Bees in a Podcast. We would like to give an extra special thank you to our audio engineer, James Weaver, and to our podcast coordinator, Jacqueline Iyenje. Without their hard work, Two Bees and a Podcast would not be possible.
For more information and additional resources for today's episode, don't forget to visit the UF-IFAS Honeybee Research and Extension Laboratory's website, ufhoneybee.com. Do you have questions you want answered on air? If so, email them to honeybee@ifas.ufl.edu or message us on Twitter, Instagram, or Facebook at UF Honeybee Lab. While there, don't forget to follow us. Thank you for listening to Two Bees and a Podcast.